We're surrounded by averages all day, every day. Sports stats, weather forecasts, you name it. But what if I told you that one of the most common stats out there is, well, it's often lying to you? Seriously. Today, we're going to pull back the curtain on this flaw of averages and give you the tools to see what the numbers are really trying to tell you.
All right, let's picture this. You're starving. You order a pizza. The place says, hey, we've got a 30-minute average delivery time. Sounds pretty good, doesn't it? But is that really the whole story?
Okay, so check this out. You've got two options. First, there's reliable pizza. Their delivery times? 28, 30, 32 minutes. Man, that's rock solid. You know what you're getting. Then there's wildcard pizza. Their times are, well, they're all over the place. 10 minutes, 30 minutes, 50 minutes. So be honest, you're hungry, friends are on the way, who do you call? It's a no-brainer, right? You're calling reliable pizza. But here's the kicker. And this is where it gets interesting. If you actually do the math, they both have the exact same 30-minute average. Wild, right? This is the flaw of averages in action. The average points to the center, sure, but it tells you absolutely nothing about consistency. So the big question is, how do we measure that chaos? So here's how we're going to break this down. First, we'll start with the basics, finding the mean. Then we'll dig into the real story with something called variance. After that, we'll make it practical with standard deviation. And finally, we'll tie it all together and see why this is so crucial for quality. Okay, let's dive right in. Part 1, the starting point, finding the mean. So mean is really just the fancy statistical way of saying average. I love this analogy. Think of it as the center of gravity for your data, right? It's that one perfect balance point for all your numbers.
And you already know how to calculate this. It's super simple. You just add everything up and divide by how many numbers there are. So for our wildcard pizza, right? 10 plus 30 plus 50, that's 90. Divide that by 3, and boom, you get 30. Easy peasy.
But again, and this is the key thing, the mean only shows us the center. It tells us nothing about whether our data is packed in tight, like reliable pizza, or just completely all over the place, like wildcard pizza. It's totally hiding that story of consistency.
So how can we actually slap a number on that inconsistency? Well, that's where we get to part 2, the real story, measuring variance.
Okay, so variance. This is the tool we need to measure that spread. I like to call it the wobble meter for your data. If the variance is low, everything's tight, stable, predictable. But if the variance is high, well, that's when things get chaotic and super inconsistent. So how do we find this number? It's just a few steps. Stick with me here. Step 1, we already know our mean is 30. Step 2, we figure out how far each delivery was from that mean. So the 10-minute delivery, that's 20 minutes early, so let's call it minus 20. The 30-minute one was right on the money, so that's a 0. And the 50-minute one was 20 minutes late, so that's a plus 20. Okay, step 3, and this is the clever part. To get rid of that negative sign, we just square each of those distances. So negative 20 squared is 400, 0 squared is still 0, and 20 squared is also 400. See how that works? Now for the last step, we just take the average of those squared numbers. Add them up, divide by 3, and you get a variance of 266.67. Okay, so that's a number. It's a big number, which tells us there's a lot of variation for sure. But what in the world is a squared minute? Like, can you even picture that? No, right? It's totally meaningless in the real world. So this number, while correct, isn't very useful yet. And that brings us perfectly to part 3, the practical yardstick, standard deviation. Right, so we're stuck with this big, clunky variance number. It's not wrong, but it's just not practical for telling a clear story. So let's make it useful. And the fix is actually super simple. It's called the standard deviation. All we do is take the square root of that variance number. That's it. This one little step undoes that squaring we did a minute ago. And like magic, it puts the number back into a unit that actually makes sense to us, minutes. What it gives us is a standard or typical distance that any one delivery is likely to be from that 30-minute average. So we take the square root of that weird 266.67, and we get 16.33 minutes. Now we are talking. This number is something we can actually understand. It's telling us that a typical delivery from wildcard pizza is going to be off by about 16 minutes from the average. That is a massive, massive swing. And this right here, this is the aha moment. Let's put them side by side. Both have the same 30-minute mean, but look at the standard deviation. Reliable pizza, a tiny 1.63 minutes. Wildcard pizza, a whopping 16.33 minutes. Bam! The standard deviation tells you the entire story in one glance. It shows you who's consistent and who's just a total gamble. Okay, let's zoom out. This brings us to our final part, the big picture, and why these simple stats are absolutely critical for quality in just about everything. So think about it. You now have this awesome little statistical toolkit. The mean, that helps you locate the center of your target. The variance, that measures the total raw spread. And the standard deviation, that's your practical, easy-to-understand yardstick for that spread. And believe me, this isn't just about pizza delivery. Think about manufacturing, software development, even healthcare. Entire quality control frameworks, like the famous Six Sigma, are built on this one core idea. You have to understand and then systematically reduce variation. Because here's the bottom line, and it's so important. You simply cannot control what you don't measure. As soon as you use a tool like standard deviation to put a hard number on that inconsistency, well, that's the first, most critical step you can take towards making things more reliable, more predictable, and frankly, just a whole lot better. So, I want to leave you with this question. Think about your own world. Your daily commute, your morning coffee routine, your workouts. Now that you know how to measure consistency, how consistent is your world, really?